Hello students, Lynette here. Welcome to my time value of money teaching notes. I would like you to print these notes and follow along as I do this discussion with you on the podcast, and also use it to supplement chapter 6 in your textbook. You can see the topics I'm going to do as I cover these teaching notes, starting with the introduction and simple interest versus compound interest. Are you ready to get started? Let's go. Perhaps some of the easiest things to understand as you're studying time value of money is the calculation of simple interest. The formula to calculate interest is principal times the interest rate times the time. So principal times rate times time. And in my first example, I'm going to show a calculation of how to compute interest under the simple interest method using 10% for 4 years. I start with $1,000. The end of the first year, 1,000 times 10% is 100. Add the 100 to the principal and you're now at 1,100. You start the next year and you still earn interest just on your initial principal balance. 1,000 times 10%. You earn another 100, now you're up to 1,200. You get the idea now. Let's see if you can finish this table. Guess I should have said put that on pause, huh? Anyway, come back, and how'd you do? On the end of year 3 is still the original $1,000 deposit at 10%, earning 100 for 1,300, and the same for year 4. Now earning 1,400. That's an example of a simple interest calculation. Let's move to one that's a little more complicated. Let's do a compound interest calculation. One where you earn interest on interest. Still 4 years, still 10%. You make the initial deposit, it's $1,000. At the end of year 1, you've earned $100 on it. It's 1,100. But notice at the end of year 2, you're now getting interest on 1,100 at 10%. Equaling 110. So your balance has increased to 1,210. And notice you earned interest on that interest. On compound interest, you get to earn interest on the balance that's being brought forward, not just the initial deposit. Take a moment, put this on pause, and finish the table for me. Welcome back, and how did you do? Let's go to the end of year 3. I know you brought down 1,210, times it by 10% and got 121 to increase your balance to 1,331, and then started with that for the end of the 4th year, hit it with 10%, 133, and ended at 1,464. With simple interest, we ended at 1,410. And with, compound interest, we ended with 1,464. What can be said about this? Which one has the higher ending amount and why? And the answer is compound interest has the highest ending amount because of the effects of earning interest on interest. An additional $62 of interest was earned. If that's not interesting to you, add a few more zeros. Then it will be very interesting. Get it? Interesting? Ah, funny. Well, we've looked at the difference between simple interest and compounding interest. Let's check out one more thing. Let's see what happens when you compound interest more frequently. We're going to do it semi-annually. So let's keep our 10% annual interest rate, but since we're going to do it twice a year, let's use 5%. And calculate where we'd be. You make your initial deposit, and at the end of 6 months you earn 5%, so you're at 1,050. Bring that down, hit it with another 5%, 10% a year, 5% now, and that takes you to 5,250 for a total of 1,102.50. You put this on pause and continue this chart for me for the next 2 periods. Welcome back. So, as you can see, when you take the balance and hit it with half the interest rate and times it but twice as often, When you get through with compounding 10% semi-annually for 24 months, you end up with $1,215.50. So, after 2 years at 10% compounded twice a year, you have $1,215.50. Let's back up a little bit and look at the same period of time compounding only annually, and you'll see that same period of time you have $12.10. It could accurately be said that if you compound more often than just annually, that you will end up with a greater balance in your account. So what's the effect of compounding semi-annually? It drives up the effective rate of interest. And again, add some more zeros and it'll be more interesting. Remember those ideas as we move forward through the book. Now, let's chat for a minute on solving time value of money problems. There are several ways you can time value of money problems. You can solve them. One is by hand with the successive interest computation, which is pretty much what we did above. Those are called fund accumulation schedules. You can do it by mathematical formula. You can do it by interest table. And you can do it by calculators that have a time value of money function. In this class, we're principally going to do the two methods, tables and calculators. And notice I've suggested a time value of money calculator for you. You can get a Texas Instrument Business Analyst 2 or Business Analyst Plus. And it's good, it's inexpensive, and it will last for your studies of accounting. You're going to need to have a calculator with financial functions, and that one will work nicely. You are responsible for learning how to make your calculator work. The charts can be found in your book. So when I say interest table, those are charts, and they can be found in your book. Students who do the best in this class understand the charts and how they work, because I think a lot of understanding for what happens with time value of money comes by understanding how those charts are made. And students who do that and then solve it with their calculators seem to do the best in upcoming chapters where we're using these techniques. Copies of the charts are available in your Connect library. Please print them and have them available for the remainder of your intermediate studies. From now on, time value of money questions are fair game on all tests. There is one more thing we need to do. Lots of times you're given an annual rate, but told to compound for periods that are not annual periods. So you need to be able to make some accommodations. I've made the following chart below so you can have a chance to convert. Let's start. I have a little sentence there you can read for how to do it, but let's start just by doing it. If you have 12% and it's a 5-year loan and you compound annually, the interest rate is 12% and the number of periods is 5. If you have a 12% loan and you compound semi-annually, that's going to have you divide that interest rate. And so you're going to have an interest rate of 6%, but you're going to compound it twice a year. So 5 years times 2 times a year is your number of periods is going to be 10. So I equals 6 and n equals 10 if you're going to compound semi-annually. If you're going to compound 12% quarterly, which you're doing it 4 times a year, 12 divided by 4 would be 3% per period, so I would equal 3. And the number of periods you would do that would be 5 years, times 4 times a year, so 5 times 4 should be compounding it, n would be 20, so I is 3 and n is 20. Put this on pause for me, will you? And please do. A 12% interest rate compounded monthly would mean 1% per month, or I equals 1. And if you did it for 5 years monthly, you would end up doing n equals 60. Why would I be interested in you being able to convert a 12% rate to an interest rate per period, and a number of periods. Well, most of the charts we're going to use require that you know the number of n's, and n is the first column, and the number of interest rates, which runs around the top column. So if you're doing 1% a month for 5 years, you would have I equals 1%, but n would be cleared down to 60, and obviously I don't have that long of a table. That's why you need to be able to do the conversions. Well, the interest tables are in the back of your book. You can also print them on Connect. The interest tables are on P1 at the back of your book. And table 1 is the future value of $1. When I write that formula out, I say the future value of $1 equals the present value times an interest factor with some number of periods interest rate from table 1. If I'm looking for a present value number, I'll send you the table 2, and we'll give you the present value, and you'll times that by a future value you're given, with a present value factor from table 2, where some n and some I intersect. For future value of annuities, you'll go to table 3. For present values of annuities, you'll go to table 4. For future value of an annuity due, table 5. And present value of an annuity due, table 6. I completely understand that you probably don't know what all of that means, but by the time we're through with this chapter, you sure as heck will. This chapter, wow, I don't know what I did, hold on. Well, that was fun with media. Back to the topic at hand. So print your interest tables from the back of the book, but you can find them on Connect, called Time Value of Money Charts, and we'll learn those as we go along through the rest of the book in this chapter. I think you'll find it fun, and here it comes. Interesting. Talk to you soon. Then we'll see you in part 2.